Hi everybody, this is 11B, relative velocity. So let's look at this. In a game of football, two players find themselves running towards each other. A wide receiver is running east, we'll do that to the right, with a velocity of VW for velocity of wide receiver. A distance XC ahead, the wide receiver sees a cornerback headed directly towards him at a different velocity, VC. The wide receiver and cornerback continue running toward each other at constant speeds. The location where the cornerback tackles the wide receiver is XT, is measured from the wide receiver's initial position of X equals 0. Okay, that's important, right? Should have told us that right off the bat. So the initial position is X equals 0. Draw a diagram of the situation. What's going on? Okay, so let's put our wide receiver over here. Okay, well, here's the ground right here. And so he is over here. And then on this side, we've got our cornerback. He's over here. Okay, so let's add some other information on here. We will say that this is X equals 0. And that this distance right here to here, this is, he said he saw him XC ahead. So we will label this XC. We've got some velocities to add on here. So the wide receiver is going a velocity of V sub W, and the cornerback is going a velocity of V sub C there. One last thing I gotta add on here is the distance at which they get tackled. And so somewhere along here, it's not clear by the way that this is initially set up, but somewhere they're going to meet, let's say, and that distance right there is X sub T, where the wide receiver gets tackled relative to their initial position of 0. Okay, so now, we might come back to this in just a second. So let's put this here. It says, if the cornerback runs faster, would the location at which the cornerback tackles the wide receiver, which remember is X sub T, increase, decrease, or remain the same? I think we need to be clear, like with this distance right here, increase, decrease, or remain the same. Well, I think we'll get the faster the cornerback runs, the sooner he's going to meet the wide receiver, the less distance the wide receiver is going to be able to go. And so in that case, it is going to decrease. And again, so let me just briefly say this. The faster the velocity of the cornerback, the less time, right, before the collision, which means less distance traveled by, traveled by the wide receiver before they get tackled there at X sub T. Okay, so next up here, it says we've got two students, Angela and Blake, attempt to develop an equation. Whoops, sorry. Let me move this down here. Attempt to develop an equation that can relates the given variables to predict the location at which the wide receiver and the cornerback tackle each other. The equations were developed so that only the magnitude of the velocity of each player gets substituted. All right, that's important. Each of their equations is given below. Here's Angela's equation and here's Blake's equation. Regardless of whether the above equations are correct, which student's equations agree with your reasoning from part B? So Angela's, Blake's, both, and this should say neither, so let me put the blank right there. Well, let's look at Angela's. So we just said the faster the velocity to the cornerback, then the smaller XT is, right? So the faster he goes, then the shorter this distance will be. Well, Angela supports that, because the velocity of the cornerback is down in the denominator. So the larger and larger VC gets, since it's in the denominator, the smaller and smaller X sub T will be. So Angela's works. Let's look at Blake's over here. So Blake's has VW minus VC because he's going the other way. So the closer and closer VC gets to W, the smaller and smaller this term in the parentheses will be. And so the smaller and smaller the overall fraction will be since this is in the numerator, to a point, which we will get to in a second. So you could say that Blake's also supports it. So you could check both. You might say Angela's or only, but because Blake's is going to run into a problem, which is going to come up next. But Blake's will work to a point. As VC approaches VW, then this term will get smaller and smaller and smaller. All right, so next up, it says a third student, Carlos, noticed that Blake's equation cannot be correct for reasons not described by the reasoning given in part B. Without deriving the correct equation, how can you tell if Carlos's claim is correct? In other words, describe why Blake's equation does not make physical sense. Well, let's go back to this problem that we said we're going to have here on this one. So what happens if VC gets bigger than VW? Then this term right here, in other words, the cornerback is going faster than the wide receiver. Then this term right here becomes negative. And if this term is negative, it's saying that the tackle position will be negative, which means the tackle position's somewhere back here on the other side of the wide receiver. That can't be right, no matter what. Even if the time is 0, he's not going to be tackled back here. If the time is 0, he'd be tackled right there. So that's a problem with this equation right here. So if VC is bigger than VW, this whole term becomes negative, which makes the position negative. Okay, last part here. It says, in terms of the variables given in the equation, quantitatively demonstrate that Angela's equation is correct here. Okay, so we need to show that Angela's equation is correct. So let's start to solve for this. So first off, let's look at where the position is going to be. We're going to do the third equation basically and say that the final position of the wide receiver is equal to the initial position of the wide receiver plus the velocity, initial velocity of the wide receiver, which is VW times t plus 1/2 a of the wide receiver t squared. Well, there is no acceleration, so that's gone. And we set the initial velocity of the wide receiver to be 0, so let's clean this up a little bit. By the way, the final position of the wide receiver is where they get tackled. So the position of tackle is the velocity of the wide receiver times the time. So now, we don't know time. So to solve for this, we're going to have to get another equation that solves for t and then substitute that in here. Or let's go ahead and solve this one for t because this is a nice simple equation. And so the time will be the position of tackle divided by the velocity of the wide receiver. So let's do the same thing again. Now let's do it for the cornerback here. So we're going to do the same thing. The final position of the cornerback is equal to the initial position of the cornerback. And then we'll put a minus here for the velocity being the other way. The initial velocity of the cornerback times time. And again, the cornerback doesn't have any acceleration, so that plus 1/2 AT squared part is gone. And the negative again comes from the fact that I'm already calling this a negative velocity. Let's take this time and plug this in here because they're the same. By the way, the final position of the cornerback is also the position at which they get tackled, so that's the same. This we can just call XC because that was what we called the initial position of the cornerback, minus VC, and then times this time, so the time is the position at which they get tackled divided by the velocity of the wide receiver. So now let's look at this. We've got to solve for this position. We've got it over here, we got it over here. So let's take this whole term right here and add it to this side. So we got the position at which they get tackled plus the velocity of the cornerback times the quantity, position at which they get tackled, XT, over velocity W equals XC. All right, so now what I'm going to do is I'm going to try and solve for XT. So I'm going to factor an XT out of each term, right, or part of the term right here. And so I'm going to get this, XT times 1 plus VC over VW. Again, I pulled the XT out of there. That's where the 1 comes from. I pulled the XT out of there. That's where we get VC over VW. All right, and all of that is equal to the position of the cornerback. So now, just about there, 2 more steps. I'm going to divide all of this over to the other side here. So the position in which he gets tackled is the position of the cornerback initially over top of 1 plus VC over VW. And so how do I get to this final equation in the form they did? I'm going to multiply both the top and the bottom by VW. So again, basically imagine I multiply it by 1, so I'm not changing it. So VW over VW times this. Here, let me write it off to the side here. I'm going to multiply both the top and bottom by VW. And so that's just multiplying by 1. So that gives me in the end the position of the cornerback times the velocity of the wide receiver. This I'm going to distribute into this term. So VW times 1 is VW, and VW here will cancel out with that VW and get you velocity of the cornerback. Oh my goodness, that is a big pain to get it in the exact format that they had it on the problem.